So we are going to talk about Linux cybersecurity, and in particular today we're going to focus on mandatory access control, or MAC. This is a lesson which is the third of this series. To find out why it doesn't want to move, give me a second. Yeah, so it's the third lesson, and we're going to talk about the Linux security module, or LSM, various mandatory access control concept. What are the general principles, and then we will focus a little bit on CentOS and SELinux, and then we'll propose some workshop. So this lesson is following lesson that we have already had on what's happening around the boot, on which I insist everything which happened before the boot is something you don't see after from Linux. So you need to be very careful. We also had vision of what can be done with discretionary access control, which are still very useful tools and that should not ignore, but that the user have capability to modify by themselves. Now we are going to enter a new world of the mandatory access control module, which is, as I've said several times before in the previous lesson, the domain where the user does not have the capability to change things anymore, and this is an area where the security is enforced by the admin, and the user has to keep with what is going on. So, what is a Linux security module, or LSM? In 2005, the NSA wanted to add capability to do a mandatory access control into Linux. By default, as I've said, Linux, like most of Unix, had a discretionary access control. And Linus Torvald did not really want something written by the NSA that nobody could check to get directly into the kernel. Too much of a risk for backdoors. And I didn't want to have a single system. So he actually proposed to make a model where we will have a third-party policy module that would plug on top of the LSM. And the LSM would fundamentally describe the generic concept of having, for example, subjects, which are, for example, a process or a user, which is making actions on object, for example, a file, through system calls. And when the system call arrives in the kernel, we would make sure that before being executed, the LSM is called with a clear identification of who is the subject, or what is the subject, and which resource or object in the vocabulary of SELinux it is actually trying to modify it. And it also did add a concept of class. We will see a little bit later why that was included. It's for a very advanced security module. This being said, obviously the NSA still decided to provide SELinux, but also a few others made it up and started to use LSM. Today there are 3 systems using LSM which are very active and well maintained. SELinux, obviously, which is most likely the biggest one, AppArmor, and SMAC. So SELinux is used by Red Hat and CentOS. Red Hat being the biggest professional distribution in the world, it means that quite a lot of people are using it. AppArmor is used by default by Ubuntu, by OpenSUSE, and by SUSE. So both of them have professional distribution, and are still quite well spread out, even if they are not used as much as Red Hat. The third one, SMAC, is coming from the embedded world. Originally, it was developed as a simple version of SELinux, and that to do embedded devices was used for the first time in a commercial television from Philips, and now is used in Tizen devices, and Samsung did a lot of investment in SMAC to make it very quick on small devices, and it's also used in automotive grade Linux for the same reason. A bit less powerful in capability, but when you want to do the basic things, it does exactly the same as the other ones, just happen to be quicker. From an implementation, there is SELinux and SMAC are based on similar models. They are the label of the application, or the label of the subject, if you want, and the label of the objects or the resources in this graphic are kept in extended file attribute, while in AppArmor that's not done like that. You have metadata describing them, which means that AppArmor is independent from the file system. So you have also a few other ones that either are open source but less maintained. Tomayo, I forgot the exact name, is one of those. But it's fundamentally not maintained anymore, so you should not use it. GR Security has done some inroad in embedded devices, originally because it was pushed by WinRiver, but it is not really open source, and it doesn't use the LSM. It's different. It actually patches a kernel to do the same thing. There is a big battle happening regularly between the maintainer of GR Security and Linus Torvald. Actually, WinRiver has stopped to use it for that reason, and except if you have specific need to use it, it's most likely a better idea to stick to a standard one maintained SUSE LSM. So now we're going to focus on SELinux or SEL, because that's what CentOS uses, and that's what we have selected for our workshop. As I've said, started in 2005 by the NSA. That objective was really to have a security defined by the administrator. And you have policy which are controlling subject and object. So the subject are the people or the feature which are actually affecting object. So, for example, a user, a process, a flow is a subject because they are capable to affect object. And object are the receiving end of it, so file and I/O, for example. I repeat again because it's a very important point that leads to a lot of surprises. SELinux label for subject and for object are carried over the extended attribute of the file system. Now, in Linux, most file systems support transparently extended attribute, but the FAT doesn't do it. So that's one first point that you need to remember, and as we've seen in lesson number 1, the FAT is actually used at the boot time. This is typically where the UEFI is going to take the kernel and the initRD. The second area where you can get it wrong is in initRD itself, as we have seen in the lesson 1 around the boot. The initRD traditionally is an archive, CPIO archive, which includes microcode to update the CPU dynamically at boot. And then you have another archive which has an image of the init RAM-FS. That image, by default, is in CPIO. CPIO does not support extended file attribute. So if you activate SELinux, your initRD will have to be not configured as default. It will have to be most of the time a CPIO archive with a microcode first, but in that CPIO archive, beside of the microcode, you will have a disk image most of the time as a zip format of an ext4. It's a bit more complex to mount it. Take a few tenths of second extra boot time. But that allows you to have an initrd with extended attribute, which means that if you have to execute daemon from the initrd, they are going to have the right label from day one. And it's very important because label cannot be changed on a running process. There is no way to change it. So if your systemd starts with the wrong label, you're not going to change it afterward. Let's look at the architecture of SELinux within a model of and implementations for LSM. So what we see on the left is that we have a request coming to the kernel. We need to have that running for the entire LSM. Let's see why it's not happy. Stop script, continue. Okay. Let's come back to LSM. So we have on the left a request coming on the kernel. So typically it's a subject trying to do some action on an object. For example, a user through a command ls trying to read a directory which is opening a file. What's going to happen? The LSM is going to subcontract the request to the SELinux module. And that SELinux module is going first to check if that answer is already available in a cache, which is the access vector cache. That's a very important point because obviously policy are described as text and there's no way we're going to compile them every time we have a request. Your system would become very, very slow. Obviously, if that answer is not available in cache, then you have to go to the policy and get the real answer. So that's the basic principle. Now, if we try to go a little bit deeper in the way it works, so we are doing something, we find out that there is a bit more complexity to it. The first one is that it doesn't really change, but we have to get the policy somewhere in the file, and we may have multiple policies, so we have to get a configuration system which say which policy we actually are using. We have to be able to compile it and make it in a fast, understandable format. Then we have our SELinux aware application, which has a right tag and potentially have specific policy which have been downloaded for those applications to make some special functions, which also add a little bit of complexity from the first graphic. And finally, on the bottom left of this graphic, we have the log features and the file system with the support of the label through extended attribute, plus an extension for network and USB devices, connectivity in general, because they don't really behave exactly like files sometimes. So there is a way to pass tag over TCP/IP connection. Now, it's not that practical to do it, and there are a lot of limitations to it, and it's not that reliable, to be honest. But it is available for some specific case. It can be practical, but where it's really useful is when you are internal to the same system, because then typically instead of using traditional socket, you're going to use Linux socket and or Unix socket as they're called, which are actually capable to carry a label in a very reliable manner. So in that case, you will be able to really identify a subject extremely well. And so that's interesting. For example, if you have a database, the database is local, you have all the facilities to do that. Now, you have your SELinux running. Yes, very good. So it's enabled. You can see that with your SEStatus command line. There is no capital on S, but my presentation software insists to put a capital on the first letter. You could have it enabled or disabled. If it is enabled, you could have it permissive or strict, and then you will have a policy name that will be indicated. The traditional policy by default is targeted. You have to know that by default, when you do an installation of Red Hat or CentOS, you have SELinux enabled, but it's in permissive mode. What does it mean, permissive? It means that if there is a violation, it's not going to kill or reject the request, but it's just going to log an error. So if a user does an action which is forbidden, it's just going to log an error. Why is this such? Because a lot of things actually do not work when you start to do strict enforcement of policies. And a lot of people use that for learning. So more or less it lets a system run for 24 hours and they say, okay, nothing special happened during these 24 hours and everything that the system has done is normal, and so I'm going to put that in my policy. I have to say that I don't like that system. It's against my general principle of whitelisting, and as you all remember, the whitelisting definition concept is everything which is not explicitly allowed is strictly forbidden. This permissive mode with a log and capability to create a policy automatically out of it goes in fact against this whitelisting concept. You don't really know what you do, you just say, okay, my system has done it, and any violation that it has done, I'm going to say it's okay. Any violation that it has not done, maybe it should have, and you may have policy which have a lot of holes, but you will not see it. So it is, in one way, pretty weak. The good thing is that as long as you do standard things, the people maintaining the SELinux standard policy and with that team, they are smart, they are very smart people. So what they do is pretty sensible. And so as long as you understand the world, that's reasonably okay. But if you do anything out of the default, you're going to be much by your own, which is one of the big problems with SELinux. So, as I've said before, we have the concept of object and subject. Now, subject can affect object. In order to simplify the writing of the rules, we have the capability to group subject in the concept of domains. For example, users. And we can create different types of users. Basic users, admin, staff, guest, people having access to graphics system, people having only access to text command line. There are things which can be done pretty simply like that, by grouping. In such manner, we can also group objects. And the objects are manipulated by subject. But what we can do is that we can make group with them, and we call them type. For example, we could have the admin user could be one domain, and we could have a type of command which are the administrative command. Traditionally, they're only accessible over root, but if we do such a policy, even if you have the root password, but your user is not a member of the admin, even if you have the sudo password because you succeeded to hack it, or you succeeded to crash a software which was temporary using super user mode, you will not be able to execute the command which have been subject to a policy of restrictions to be only activated from the admin user group. So this is where the power of the concept like mandatory access control come into play, and in particular the implementation of SELinux. Let's look a little bit how this is done inside Red Hat. You have to find out that by default users are not they're actually unconfined. So the user domain by default is unconfined, but you can confine it, but by default it's not. If you start to do confinement, then you can do things like describe in this table, and what we can see is that for example, if I take in a class of user system admin, obviously system admin can do everything. including becoming SU. Now, if you are only staff, you can do as well everything you want, but you still have to go through sudo. You cannot do SU anymore. This said, if you can do sudo, you can do sudo bash. Now, you could write a specific SELinux rule that says that sudo is not allowed to call bash, and then you would stop people to do a fake SU by doing a sudo bash. And if you are a regular user, you are not allowed to do sudo. Oh, we already have seen that in our previous lesson on discretionary access control when we talk about configuration file as well. And I told about sudo, and there is a configuration file which allows to decide who has access to sudo. And I told you that in numbers of distribution by default, if you are a member of the wheel group, you have capability to call sudo. If you're not a member of wheel, you don't have that capability. But here you actually enforce it in such a way that cannot be changed. Except by the admin side. Where you can see really that it becomes something you cannot do, it's on the last line. The last line very clearly define a guest which is using X, so connecting to the graphics subsystem. And that guest is only allowed to access to the network when he's using Firefox. That's something you cannot do even with extended access control from the discretionary access control. Why? Because if you can access the network, you have access to the Ethernet interface, for example, the Wi-Fi, for example, /dev/eth0. And in the discretionary access control, you don't have the concept of which application is actually calling and trying to access. Here with SELinux, if you have put a specific tag on Firefox, for example, you have created a domain which is a web application, you can say that in even graphic or browser, you can say that X guests have access to that. And they don't have access to anything else. So it's a quite practical way, and it's very easy to write a policy which has a default which is no to everything, and then you have the exceptions, and then you can do whitelisting. Now, SELinux allowed to go further than that, and it's the only one that actually allowed to do this multi-level security. That's the main difference with SELinux and Apamoor on Mac. This said, most of people don't need this level of complexity and will never use it. But NSA wanted to have it, so that really was they did actually. SELinux, they wanted to implement the Bell LaPadula mandatory access control model, which was known in the Multics old system, which allowed to, on top of the concept of object subject, you have the capability to add a class. And then only if you have a peer access to a class equivalent, you can actually execute. So probably it's just add another level of capability to tag, which will allow to do more discriminations. This time not only by the first label, but by an extension of a label associated to that, which give a level. As I've said, it becomes quickly complex. I would say even extremely complex, which means that troubleshooting will be required most of the time. Soon, if you activate that, nothing will work. Getting it compatible with graphical application is a very complex exercise that most people would not do. And most of desktop application would not work either. So it's a very specific use case. Use it if you need it, and then you will have to use SELinux, but you then have to plan to spend a lot of time investing into how it works in detail, because otherwise either you are not going to be protected or it will not work. With this, we arrive to the summary of SEL. So as I've said, it's a very powerful system. Unfortunately, it's so powerful that it's almost impossible to master it. You have to trust ready-made rules. The good thing is that people doing them are pretty smart and we hope are honest. It helps a little bit that generic policy are actually maintained in the open source. We will look at them a little bit later. You have the link here. But nevertheless, the level of complexity is such that it is very difficult to know what you're doing. You have to remember that outside packages are not included in SEL. It can be done, but they are not by default. And so by default, they are absolutely out of control. And the way the default policy is written, it's a targeted policy, which means that it only controls what's in nodes. It's not a traditional full whitelisting where anything which is unknown is forbidden. No, it does actually fit to the use of a general distribution, and in that point, the way the targeted default policy from Red Hat and CentOS is implemented, it's very equivalent to what is done by AppArmor or in OpenSUSE or in Ubuntu, where they probably have selected a few risky applications and created a jailing around them, for example, the web browser. But if you are in a company, likely you will have some business applications which are not going to be provided by the distribution, and those could be very well candidate at problem, and so you will have to find a way to trust them. SELinux, like AppArmor, have a learning mode called permissive in SELinux. For information, SMAC does not have it, so you really have to know what you do when you activate SMAC. But it is one way to make a security. As I've said, you let your system run for 24 hours and you expect that if nothing happened strange during that day, it was a good day, it was a normal day, and everything it did was supposed to be done, and you do it. But obviously that doesn't stop you to potentially have problems with other things. The point to remember is that because SELinux, like SMAC, but not like AppArmor, relies on extended attribute on the file system, you can have very tricky things happening when you do replications of file, backup of file, because this extended attribute can be not copied. For example, if you use an old version of tar, which is something I've seen recently with an Ubuntu LTS. So some utility or people using a zip, and then they lose them. But also you can lose your extended attribute when you do a copy, because in that case, extended attribute of the file is not the extended attribute of the origin, but actually the extended attribute of the guy who did the copy, except if you request to preserve the extended attribute, which assumes that you have the right to do it. So there are quite a few ways to easily get into big mess, and so better to script it, because normal user will not understand why it doesn't work. With this, I will end the SEL. I've added to this lesson one specific type of control. We already talked a little bit about it, but I believe that it fit quite well there, because it's a complementary, but it's not always applicable, which is the sec-comp BPF. So it's a system called filtering. So it allows to set a filter on what call you can do into the kernel. It's been there for quite a bit of time. It's used mostly by browsers and by container technologies such as Docker. The filter are expressed using a language which originally was designed for packet filtering. for Berkeley, which is a Berkeley packet filtering system. But in that case, we don't filter packet, it's just used as a language to define rules, to what you can call, in which condition, for which reason. What you have to know about it is that while on the paper it can look like a mandatory access control, it's very different. First, it has a serious impact on performance, which is not the case with SELinux or SMAC. SELinux could potentially take up to 5%, but not much more than that. Here we're talking system can easily go to 10 or 15% of CPU, even more. But more than anything, it's only applicable to application by patching them. So you have to get the source code and you have to compile the application. So you cannot apply it on top of an existing application. And finally, the restrictions are not inherited by children process and nor by thread. So you really have to know the application and know what the application does. The good thing is that if the application is then hacked, then you are saved. And a good example is a browser, where you don't execute external code in a browser. You execute JavaScript. And you know, that JavaScript, you don't want it to be able to do things you don't like. And so putting a set of filter on the virtual machine is very interesting. But with JavaScript doing multi-threading, we're potentially going to have some sort of side effect. But you know, in that case, it has a lot of sense to use it. But as a general security system, even if it looks quite good, it's actually not. There is another model of security enforcement that you could use, which is dropping privileges. But in a similar manner, dropping privileges is something that you actually do from the application. The good thing is that the inheritance in that case works. So dropping privileges is definitely worth to implement. And systemd starts to allow to make external control of it. So that is a technology that likely starts to have some applicability in configuration of system. But in a nutshell, for most of people, using a mandatory access control can allow to do all of that in one single place. So this graphic is just for you to study quietly, and it tells you what are the different ways you have to implement security. There are plenty of ways of doing it. You have the capability, that the last one I talked about, you know. There are a lot of capability into Linux, which traditionally root used to have all of them, but actually you can create a UID 0 which does not have all the capability. You can drop them. You have the namespace, we'll talk about that later. We talk about seccomp. You have SELinux. And in one way, they all do a little bit the same. And the traditional access control as well is there. So these are all the mechanisms you have to protect the system. I would tend to say that for normal user, using the discretionary access control and the configuration files, don't forget those because they are very useful, associated with the mandatory access control, that's likely going to be enough for normal user. If you are the extreme user, that's another world. Then you have to look at all the capability, and you may want to have belt and braces and implement dual level security, even sometimes triple. For example, you could have a configuration file that stops things to happen. You could have a policy in SELinux stopping it to happen again, and then you could have a drop of capability, making it impossible as well. And then if someone succeeds to break it, as we say, you know, it's not a question to know if you're going to be having one day a problem of security. It's a question to know when. And you have no idea how they will come in and how they will move in your system. Obviously, the more you have system security, the more difficult it is for the attacker to move into your system. On the opposite side, you have a huge complexity to manage, which potentially can create a lot of holes and can also create performance problems. I would just give one past experience. In Tizen 2, we had tried to implement everything using SMAC, and we tried to create the entire system using rules. We had a big, small set of rules, 22,000 rules in SMAC for a Tizen 2 phone. And finally, what we did was a sieve. And if you don't know in English what is a sieve, it's a cooking device which allows to drain the water out of vegetable after you cook them. So it looks like a very thin net, but actually it's full of hole, and the water can get through. And our security subsystem was like that in 2002. So in 2003, we changed it completely. We made to a very simple system on the rule set of SMAC, and we implemented a database of privilege called Sanara that I will not cover in this training because it's very specific to embedded devices on Tizen and automotive grade Linux. But it's just as an example of practical life experience. So in that graphic, you have a lot of capability, but use the one you need and don't over-complexify your system. You still need to be able to understand what your system does, otherwise your security level is getting to be very low. So, my conclusion, Mac is powerful but complex, but you must master it. Now, likely you will have system using SELinux and AppArmor, so you have to master both. You may never have to touch SMAC on embedded system. It may happen, may not. It does not replace regular updates. That's an important point to remember. And validating your package from a valid source is a very important thing. It remains. Because if you implement, from a fake source, your code is going to be legal in your system, but still malicious. I repeat, because I believe I will never repeat it again enough. Everything which happened prior to the boot is not visible from Linux. So you have to keep that on eyes. And finally, in SELinux implementation of Red Hat and CentOS, custom apps are not supervised at all by default. You have to manually write your own rules to actually monitor them. So as a homework, obviously you will have to look a little bit of what is available, and I will show you a little bit of things that you could work on. I would like you to activate SELinux on your CentOS box, load the utilities, first go in permissive mode and try to make violations. An easy way is to copy a utility, like for example SSH, from its normal location into your home directory and try to execute it there, and you'll see what's happened. And then move to enforce mode and check what are the differences in when you do violation. And finally, look at how to change a policy to enable a use case, for example, where you could do a file copy and execute into the home directory. Add a user and check that user, depending on which domain you affect, what are the side effects, and using some specific command. So play a little bit with it. If you have a little bit of extra time, implement an application which is not by default covered by the target policy, and make it being covered. That's a good example. For example, GPSD having access to USB device or access to the network. So with that, I still wanted to show you a few things on the web. My email is still complaining. Yes, accept it to come. The first one is that this is the link I've given you. It's a very good source of information. It's the SELinux user and administration guide from Red Hat. The only thing I can say, you have to read it and you have to go through the exercise. It's just a must-do. It will create a very nice section of what is SELinux. Sorry, my system is dead slow. I don't know why. Likely because I'm recording these things at the same time. If I close that tab, maybe. Reload tab, new tab, close the tab. maybe close my mail, it will help. No. It's just slow. Let's go to the other one. The other one that I have picked up is from CentOS, but you have the same on that. It's hard to build a local policy module, so one which is yours. Once again, it's something you need to understand, because this is really what you have to do when you will have your own applications to protect. The next one is an overview of the default policy from SELinux in Red Hat and CentOS, what it does and what it doesn't do. It's very important to understand what it doesn't do. And the final website I wanted to share with you is actually the Git repository. Git is a service hosting source code where the default policy is actually maintained, the reference policy. You can see that there are bugs open on it, so people are still working on them, and they keep doing it. So it's not simple, you know, and you can see that those of this bug can actually be quite nasty, you know. It's but they are very complex. When you see that, you realize very quickly that you cannot maintain that by yourself. You just have to look at people doing it and how they're doing it. You know, you look at different pull requests. You know, they're not simple at all with what they are doing. You know, here we are adding support for a given file system. This has been changed one file. I just show you. You know, it's small detail that, you know, it's pretty Kabbalistic. You know, it's just adding support of a file system, which is in the case UBFS, on top of the existing one. It's pretty simple change, but just still create the capability to add it, and you can see that it's putting it in the standard object system as a standard file system. So before that, it could not be managed. It's also visible that a lot of people are working on it and are very active. You know, I have you know, 48 people working on it. So, but obviously you can see that Tellis is the one doing the most of the work and the integration. So a lot of people are. But you know, you have a lot of corrections coming in. You can see them here on the small arrow. So with this, I wish you and a good end of the lessons. Work on the workshop. Have fun. Try things. Fail. Look at the log. Go back. Make simple things, because at the beginning, otherwise you will overwhelm your capability to understand why the system is not working. And the tendency is to give up very quickly. You cannot afford to give up. You know, the people who will attack your system are smart, and you have to be smarter than they are. Okay, wish you a good time, and talk to you next time. Bye-bye.